Alright, so this video is going to talk about cotangent functions, and I'm just going to keep it to basic transformations. So let's start right away. We've got y equals cotangent of x, and you want to be able to graph it. So I've made a table of the first period, and so we're just going to evaluate the table by plugging in 0. So the cotangent of 0 radians is undefined. Hopefully you know why. If not, I'll show you in a second. Cotangent of pi fourths is 1. Cotangent of pi halves is 0. The cotangent of 3 pi fourths is -1. And the cotangent of pi is undefined. So if you're thinking about the unit circle, because that's all I'm doing in my head to think about these things, why is cotangent of 0 undefined? This is the point at 0 radians, and so the point is 1, 0. And to figure out the cotangent, we do the x value divided by the y value. It's the reciprocal of tangent, right? So 1 divided by 0 is undefined because we can't divide by 0. And then same thing for pi. Pi is over here, and that point is -1, 0. And so if I do x divided by y again, it'd be -1 divided by 0, which is undefined as well. And so that's where we have things that are undefined. That, again, like tangent, will mean that cotangent starts with an asymptote and ends with an asymptote. These are both vertical asymptotes, and that is one period of an infinite number of periods as cotangent moves all the way to the left and right, but they'll start and end with asymptotes. So take a look, right? You've got 0 and then pi fourths, pi halves, 3 pi fourths, and pi. And so once again, the distance, right, or the period is not 2 pi like sine and cosine, but it's just pi. Okay? And so 0 pi fourths, pi halves, 3 pi fourths, and pi. Okay? Vertical asymptotes, I'm going to draw them in. And then we're going to plot the points. Alright, so pi fourths is 1. Pi halves is 0. And 3 pi fourths is -1. And notice that the curve goes that way. So hopefully you already know about tangent functions. But tangent functions look actually very similar to this, except tangent functions go up to the right and down to the left, and they start at -pi halves and end at pi halves. So there is some differences between tangent and cotangent, but they are very similar in their structure. So let's do one more period. Right, and I'll just go the other direction. Seems pretty straightforward. This would be -pi, -3 pi fourths, -pi halves, and -pi fourths. Right? So you can also notice that the notches on my graph are going by pi fourths, which would be the period divided by 4. And so that's helpful to try and count out more x values as you kind of work through it. But then it's a periodic function, so it's just going to replicate it. So there will be a point in the middle. It'll go up 1 to the left and down 1 to the right. And then we'll do our best to draw what looks like a cubic function, even though it's not cubic. But that kind of graph looking thing. And we could keep making more and more to the left and to the right if we just keep adding the period. If you've watched my first video, then you know that the domain and range are going to be a little bit different to try and find, but they're not that terrible. So the domain can't be all real numbers because we have these asymptotes. And so when we're looking at the domain, last time we said you want to write an equation for the asymptote. So we said pick an asymptote. So let's pick 0. Right, that's an asymptote plus, and then what are these spaced out by? Well, they're spaced out by pi because that's the period. And so that's what we're going to put there, the period, pi, n, and we're going to say x can't equal that. So we're going to clean this up a little bit. So the domain, the better way to write this would be x can't equal pi n. Because you don't really say 0 plus pi n. What's 0 plus anything? It's just itself. So domain is x plus pi n. And remember, n represents an integer, any integer. Okay? The next thing would be the range, right? And the y values that are being used are going all the way up and all the way down. And so that would be all real numbers. All right, so that's what a basic cotangent function looks like. Very familiar and similar to tangent, but hopefully that makes sense as to kind of the way cotangent would look and why, because obviously we have different spots where it's undefined and where it's equaling different things. Okay, so we're going to do a couple examples, but once again, I'll go through this, what each piece means. Remember, this guy right here is going to be your vertical shift. And then A, it's not quite the amplitude, but it's how much you go up to the left and to the right. Or how much you go to the left and how far you go down to the right. But vertical stretch and shrink, depending on the value. If it's bigger than 1, it's a vertical stretch. If it's less than 1, it's a vertical shrink. And I'll go over those in my next video about cotangent functions. All right, so let's do 2 examples, and then we'll call it a video. Okay, so we've got y equals 2 cotangent of x plus 1. So in all my kind of stuff that I ask you to do is just break it down so that you can kind of piece by piece put it together. We want to know the a value, we want to know the period, we want to know the vertical shift. All right, all those will help us get a nice, good looking graph. So a is 2. The period of a cotangent function, it's not been changed, it's just pi. And then the vertical shift is up 1. So we're going to find our start and our end, right? And let's make sure we're very clear. This can become confusing with tangent because tangent and cotangent start and end in different spots. So tangent starts at negative pi halves and ends at pi halves. But cotangent starts at 0 and ends at pi. And if you take your period and you divide it by 4, right, that would be pi fourths. That'll tell you what your notches need to go by. So then we just count by fourths because it's starting at 0, so that's pretty straightforward. Pi fourths, 2 fourths is 1/2, so pi halves, 3 fourths, so 3 pi fourths. Okay, and that's what we have to look forward to right there. And so we're going to make our graph now. And I'm going to graph 2 periods just so that you can kind of get in the practice of it. So there's pi fourths, pi halves, 3 pi fourths, and pi. All right, and then here's negative pi fourths, negative pi halves, and negative pi. Hopefully that all makes sense. The next thing I encourage people to do is I encourage them to draw in the midline. So it's been shifted up 1. That's our midline. Okay. And then also remember tangent and cotangent both end and begin, or begin and end, at vertical asymptotes. So 0 is my vertical asymptote. Pi is my vertical asymptote. Ooh. And then we're going to graph them. So remember, cotangent, up to the left, down to the right. Put a point in the middle and go up the amplitude, so up 2 to the left and down 2 to the right. Up 2 to the left, down 2 to the right. And there's our very nice cotangent functions. All right. And now we should do the domain and range. The domain, once again, probably not going to change much since there's no shifts left or right or period changes. So if we grab 0 and do 0 plus pi n, that would just be x can't equal pi n. And the range would be all real numbers. Okay? Let's do one more. If that made total sense to you, though, feel free to hit pause and try one on your own, and then you can hit play and watch it back. But we'll get going. So here we go. I'd say that the A value is 3, but I need to do a reflection. The period is going to be pi still, and then my vertical shift is up 4. Okay, so since the period's not going to change, I've got my starting and ending at the same spot, so nothing crazy there. 0 to pi, right? So pi fourths, pi halves, 3 pi fourths, and pi. Then if we put in our midline, the midline would be up 4, so 1, 2, 3, 4. Okay, and I'll put in my asymptotes, 1 at 0. One at 0 and 1 at pi, and then we can make our graph. So in the middle, and then it's reflected, so instead of going up 3 to the left, we're actually going to go down 3 to the left, and we'll go up 3 to the right. And then we'll do our best to draw a nice graph. Hopefully that's good for you. And then after that, you can make more periods and keep replicating that. All right? Hopefully you have a great day. Oh, I didn't do domain and range. Still the same. Domain is going to be x can't equal pi n, and the range is going to be all real numbers. Okay? All right. Have a good one.